Hello, Calculus. We are going to start a new topic this evening. It's the Wednesday edition of Calculus 11-2, and we're going to talk about absolute extrema and relative extrema. So, absolute extrema and relative extrema. All right, so it's going to be a lot of blab and not a lot of calculation tonight, but we've got to do that sometimes. So it works like this. If a function has an absolute maximum, say there's a maximum at x equals b, so there's a b at x equals b, there's a maximum value. So if a function has an absolute value at x equals b, then f of b went up and hit the function and read the value of the function at that point, and we got f of b. Then if this is the absolute maximum, then f of b is the largest value that f can obtain. So similarly, if a function has an absolute minimum at x equals b, so let's say we go like that. And right here, we'll say instead of b, we'll say c. So say if a function has an absolute minimum at x equals c, then f of c is the smallest value that f can obtain. So we're talking about the absolute max and the absolute min, and it's just sort of intuitive, but we like to define our things very clearly in math. So let's define these terms more formally. So we can say this. A function f has a absolute maximum. Come back. A function f has an absolute maximum at x equals b if f of b is greater than f of x for all x in the domain of f. So that's a fancy smancy way of saying that it's the highest value. All right, so if you would write down this definition of absolute maximum, and a function has an absolute minimum at x equals b if f of b is less than f of x for all x on the domain of f. So the absolute minimum and the absolute maximum are sometimes called the absolute extrema of the function. All right, so I didn't write out everything for minimum, but it would where this word maximum had occurred, minimum would be substituted, and less than or equal to would be substituted in here. Otherwise, they're the same. All right, so now let's look at local extrema. So we often call those relative extrema. Relative or local extrema. So a function has local extrema at x equals b if f of b is the largest value that f obtains near b. So that would look more like this. Say we had a value for b, and this value in the area right around x equals b, this is the highest point. So we call that a local or a relative maximum. So a function has a local or relative maximum at x equals b if f of b is the largest value that f attains near b. So this could be a local min, because it's the lowest value around that value. And this would be another local min. Obviously, this function will go on forever, and this is not going to be the absolute maximum, but it is a relative or local maximum. So it's sort of like if you were the tallest person in your class, there you are. But if you went to the NBA tryouts, you would no longer be very tall at all. So it all depends where you are, if you could be called a local extrema or not. So let's write it out formally. A function f of x has a local or relative extrema. I'm sorry, we'll start with maximum. A function f of x has a local or relative maximum at x equals b if there is an open interval. Remember, open intervals do not include the endpoints. So an open interval I in which f of b is greater than or equal to f of x for all x in I. So that's how we formally say we're just going to look in one little interval around this point, and therefore if it's the highest, so a little interval around that point, if it's the highest in that interval, we'll call it a relative or local maximum. So if we're going to define a local or relative minimum, a function f of x has a local relative minimum at x equals b if there is an open interval I in which f of b is less than or equal to